Hello everybody. In this video we're going to talk about the software that you can use to draw the process flow diagram. And actually I got some questions from people asking how we can do this, so I thought this might be helpful to those who are interested in that. So usually I used to use this software, which is called Microsoft Visio. Microsoft Visio is one of the Microsoft Office software, and it's sold separately, so it's not in the package of Microsoft Office. So you have to buy it separately, and actually I used to use it for a long time during my undergrad, and it was really helpful and useful. And then I shifted to another software, which is CorelDRAW. It's more powerful, and it's not only limited to the flow diagrams and stuff like this. So for now I'm gonna use the version that I have, which is the 2003, and I believe there are many more software versions that are released, but this is the one I have. So I'm just making this video as a sort of description or introduction to the software to those who are interested in these kind of things. This is the main window that will open when you start the software. So just to give you a quick introduction to the software, so it is basically for drawing diagrams. There are many modules and stencils that are already there for different interests or different fields of diagrams. So there are block diagrams, there are building plans for people who do architecture stuff, there are charts and graphs, there are electrical engineering stuff that are really helpful for electrical engineers, there are mechanical engineering stuff for people who do mechanical drawing, and for our interest as chemical engineers, we are more interested in the process diagrams, and so there are some piping and instrumentation with metric and US units. There are process flow diagrams for metric and US units. So I'm gonna use the process flow diagrams since we are going to do some process flow stuff. Once you choose the diagram type that you are going to work with, you will find there are what they call shapes or stencils here. They have ready-made shapes that you can use based on the type of diagram that you choose. So there are valves, there are process annotations, there are pipelines, instruments, equipment, vessels, pumps, heat exchangers. So there are many things that are really useful and helpful for us as chemical engineers. So this is what we're gonna do, and for the sake of demonstration I'm gonna draw the famous system of absorption stripping columns, just to show you how the system works, and you can explore it yourself, or I can make more videos if you are interested in. So please feel free to let me know if you need more demonstrations on specific stuff. So you'll have here, you will see here there are a lot of toolbars, toolbars here. You will see most of these will be like Word and Excel stuff, the older versions of them. And there are other stuff here for drawing, and there are other stuff here for snapping and for object stuff, and we will go through these things if we need them. So the first thing you see that there is these rulers, and this is the layout that you're gonna put your stuff in. You can show the grid lines or unshow them depending on what you want. So I'll just keep the grids just to have them here. You can rotate the when you go to the corner, you can rotate the page by pressing Control, and you will find this, and and if the arrow looks like this, which is the split arrow, this is all by holding Control. You can resize the page. I can make it smaller, bigger, depending on what I want. I usually zoom in and out by pressing Control, and by rolling the mouse wheel. You can do this from here, based on what you want. You can make it like exactly as the width. So these are some very quick stuff just to start with. So let's say you want to draw the absorber. So you have here tray column. There is a fluid contacting or reaction vessel. This is the packed column. So I'll use the tray column, which is this. I can make it taller or shorter. It's very easy and straightforward. You'll find here that the shape that is ready-made has some nodes here, which are places where you can get input or output stuff connected to the column, and we'll go to that quickly. One thing that you will notice is that the column has something written in the bottom. If you double click on it, you'll find that this is a name that you can choose for the equipment or the unit that you're using, and I can name it as absorber, and then from this yellow thing you can move it here so you know that this is absorber. You can put a code, you can put any name that you want for your equipment or for unit, so it's pretty convenient. So this is the first thing. So for the absorber, what we want to do is to have two streams, or actually there are four streams. There is one stream that is two from here and here, and two from here and here. I will go through these quickly. So the first stream would be the gas that's going in, and as you see I chose this connector tool, and it's very nice tool. So the cool thing about it, you can choose this line from here and connect it here the same way, but the cool thing about the connector tool is that first when you have I'll zoom in here, when you have the line connected to the shape in this red node, then it means that they are both connected as two separate objects connected at this point. So if you move one of them, the other will move, or if you move the object, the line will move with it. So this is one cool thing, so you do not need to care about each line to have it reconnected if you move the object from one place to another. If you press on this, you can make the arrow, of course. The cool thing is that the connector tool will take different shapes depending on the place, so it can avoid other shapes if there is a conflict or it's going over one of the shapes, and we will see that in a few minutes. So this line would be the reach gas. And then we will make another connector tool here, going here, and we will call this the lean solvent. And then we'll have one coming out of here, which is the gas that is lean gas, or I don't know what they call it, but just the gas that is not reach in the material that we are interested in. And then we will have the product stream, which comes out from here, which is the reach solvent. So what happens, and I believe most of you know that in the solvent extraction or absorption units, is that you have the gas that has one component that you are interested in, and then you use the solvent to extract this gas from here, and then it takes the material, or let's say it's gasoline, it takes the gasoline in the solvent and leaves the rest of the stuff here that you're not interested in. And this is simply the thing. The point of having absorption and stripping system gathered together is that you want to recover your solvent. So let's say we'll have another column here, which is the recovery, or usually it's called the stripping section, or the stripping column. So it's gonna something like this. Oops. It's gonna be look like this, and we can rename it and call it the stripper, which is the stripping section. And then we can simply do the extraction of the solvent here, or the recovery of the solvent here. So usually what you would do is directly take this from here and move it here, and you'd see that the connector tool would take different paths depending on what you want. or if there is other shapes in between. So what we do here is there is hot steam or any other liquid. In this case we can call it the hot steam or recovery stream that contacts the solvent, and then it evaporates the material that we are interested in, which is the gasoline. Let's say it's gasoline, and then we will end up with some solvent here that is lean solvent, which will take it and move it there to the absorption column, and this is the system. But there are some other details here just to make sure that the unit is efficient. The first thing is that the solvent that you get here needs to be pumped and needs to be collected first. So in many cases you would see in flow sheets that people would take some vessel like this. We will rotate it 90 degrees, and from this vessel you can first take this here to collect the solvent, and then take it to a pump, so you can pump it to the top of that column, because it's a very high column, so you cannot just let it move there. So we can take one of these centrifugal pumps and move it here, and see it already connected to that line. Of course you can resize the pump because it's a huge pump, it shouldn't be that big. So we have the pump, and then you can take again the connector tool and do that, and you see it's pretty simple and straightforward process. Just connect the stuff, it's done. You don't need to do anything special or draw special shapes or anything. But the point here is that the things that you are putting into the column have to be hot, so it's easier for the gas to come out of it. So one thing people would do is to do heat exchanging between that hot stream and that cold stream. And this will be something that we can do here from the heat exchangers. You can take this thing here. So first you can just because it comes really hot, so you can just cool it a little bit, or just use his heat exchanger. In this case I would do cooling first, or this is heat exchanger, so no, I don't want this one, I want this one. This is the heat exchanger I'm interested in. So you see it allows you to put two streams here. Let's make it a little bigger. And then the cool thing here, if you move it there, you already will get this thing. No, it's not working. So you can take this here and reconnect it. It's pretty simple. Just to make sure that everything is going in the right path. And again, you can make the arrows and everything will be very logical and simple. And then you can take it here and connect it to the solvent thing. And of course it's not good to have two lines, so I will delete this and make this guy go over to there. Okay, so this sounds good till now, but still you have to have one pump here to pump that liquid up to that column as well. So you can copy and paste. You can take these two guys or three guys and copy them here. I press Control and everything would be copied, and then you can make a mirror of it. Oops, no, I don't want to make a mirror. So I wanna. It happens a lot that you'll find that there are a lot of stuff in that small space, so you can move this, and this is what I told you that is very cool thing about that software, is that it takes care of everything when they are connected. So you can move this pump and vessel here, move the stuff to, or oops, so collect them here, and then you can mirror the pump. Oops. It's a little messy. It usually happens, but you have to like little bit to tackle everything. And again, take that connector tool from here, go to here. So now you can cool your system. Of course, you will have enough time to redo or relocate the stuff if you feel they are not looking good. One thing people do as well is to have another cooling unit here just to make sure that it's cooled enough. And if you see here, you'll find that there are no cooling or coolers here, so you can draw it yourself. Just draw a circle here, and it's not going to be as good as the stuff that they are here. You can see it doesn't have these nodes that you have in each of these because it's not one of the default shapes. But you can make yours. You can make yours. It's not going to be a problem, and it's going to look nice as those shapes that they have. And another line here, and draw the arrow, then you have a cooler. If you cannot find this toolbar, I can put it here. You can right click here and you can choose the drawing toolbar. This is where you can find it if it's not already there. And I believe in the new versions you would have ribbons like what you have in Excel and PowerPoint, and then in this case you can use these as or you find the stuff in these ribbons instead of having these old-fashioned toolbars. So this is now almost everything you have. There is some stuff that you don't need to rename. I can call this the it's already named before. This needs to be named. If you want to name it, it's simple. It is the insolvent. And of course you can change the font size and everything, and if I press Ctrl A, then you can change the size of the fonts of everything, or you can change every one separately if you want. It's something extra that you can do. Sometimes here, because this is the main product that we're interested in, so in many cases, or in every case, you would find people having one vessel like this. I'm again copying. Just press Ctrl while you are dragging, and it will already automatically copy. So people would collect it here, or because it's a gas, first you have to cool it. Then you can have a copy of this. Again, the same thing. Connect it here, and then get one more connector from here to here, and then take this as the final product. So I think it looks good now, and this is the final product, if you would say it like this, or whatever you call it. So it's not meant to be the most accurate flow diagram. It's just a tutorial, so there might be other more accurate things or other stuff that I missed, but it is just to show what you have or how you can do this. And then once you're done, you can export it and or save it as a JPEG file. So you can find here from file and save as whatever you can call the name. I can say it absorber and stripper, and you can find the JPEG file format here, and I will save it in my documents, and you'll find some options. It's RBG. I don't know what is this actually, but it only gives the option of baseline, so I have no option. You can choose to change the quality. If you want to rotate it right or left, it's okay. The resolution is one thing that you might be interested in, or it's important to adjust. So these images are usually not very high resolution images, so you have to make sure that the resolution is high enough so the images are good and will be clear when you put them in the Word file or in your presentation or wherever. And the size, you can choose the size to be the screen, the printer, or the custom specific size depending on what you want, and you press OK. And then when you go to my documents, you would find this, where did I put it? Put it in my documents, I think. It's not now. My documents, I think I put it in my documents. Let's try one more time. So save as JPEG, where is the JPEG here is JPEG, and then it should be here to my documents. Okay, it's another document. So absorber and stripper. Again, the same settings, and I press OK. And now when you go to my documents, you'll find the absorber and stripper here. If you double click, you'll see everything here. It looks very, very nice. There might be stuff that are very big. You can fix this. You can take care of everything. And you see we did this in less than 15 minutes. And you can make more complex and very complicated flow sheets with this. And this is what I used in some of my presentations for the distillation tray that I used before. I used the software to do this, and other things. I used the same software, so it's pretty nice and pretty powerful for this kind of things. So this is all for today. And let me know if you are interested in more videos about Visio, about specific stuff, and I'll try to make another video for CorelDRAW, just to show what you can do with both software, and you can pick whatever you want. So I hope this helps, and I'll see you later. Bye bye.